The 12th element on the periodic table element is magnesium. All right, this is Norris Teaches Science. Today with me, Mr. Norris, another physical science edition video. Today we're going to talk about Bohr's model and electron dot diagram. So by the end of this video, you should be able to say, I can draw and read Bohr's model and electron dot diagrams of elements. So what we really, before we continue, you should have done the labeling of your periodic table, brought that periodic table back to this video because you're going to need that periodic table to do this because we're going to be looking at different elements on there. I'm not going to have a picture of it up here, so I'm hoping you brought it. So Bohr's model was the model of the atom, but Bohr focused on the electrons, placing them into energy levels. So if you can see this picture over here, this is a picture of Bohr's model. Now the components of Bohr's model are two things: circles and dots. So to figure out the number of circles, that is whatever period the element is in, or how many energy levels it has. Remember, if it's in the second period, it has 2 energy levels. The dots, we're going to be placing our dots just on the last circle because the number of dots we place is equal to the valence electrons. Remember, valence electrons are the number of electrons on the outermost or last energy level. So we're just going to place dots there. It's an important note here. The first energy level, the first circle, can only have a max of 2 electrons. The second, all other energy levels can have a max of 8 electrons. So steps to draw Bohr's model. Now, remember, I only covered about the first 20 elements, and that's where most of these steps can go apply to. When you get into like transitional metals, it gets a little bit more complex. So we're going to determine the first step is determine the period the element is in. So let me change colors real quick to blue. So we have oxygen. We need to figure out what period it's in. So if you look on your periodic table, you figure out the oxygen is in the second period. Then next step, determine the number of valence electrons the element has. So we're messing with the oxygen, we're looking for valence electrons. If you use your labeled periodic tables, you would recognize that oxygen has 6 valence electrons. Third step, we're going to place a dot to represent the nucleus. We're going to place circles around the nucleus, and the number of circles we place is determined by the period number. Since oxygen is in the second period, we do 2 circles. 1, 2. All right. Then we're going to place dots on the last circle in correct order, and we determine the number of dots by valence electrons. Since there are 6 valence electrons, we're going to be placing 6 dots. And by correct order, it's like this. You place 1 dot north, then 1 dot east, 1 dot south, 1 dot west. We have placed 4 dots. We still have 2 more. Then you repeat the process. Here's 5, and here's 6. And this is Bohr's model for oxygen. Now that doesn't mean that in some cases you may see dots on the inner circles because they're drawing all the electrons. But for me, we're focusing on the valence electrons. So let's do a little bit more practice. All right, we got neon here. Neon, first step, we need to figure out what period it's in. Neon is in the second period. The next step, we need to figure out how many valence electrons it has. Neon has 8 valence electrons. I'm getting all this information off the periodic table, the one that we labeled. So the next step we do, a dot for the nucleus. Then we need to do circles. Circles are equal to periods. It's in the second period, so we do 2 circles. Then we're going to place dots, 8 dots, because 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And that's neon. Pause video real quick. Try boron. All right, boron. It's in the period. It's in the second period. It has how many valence electrons? It has 3 valence electrons. Just so you know, I have my periodic table in front of me right now as I do this. Next step, we do the circle for the nucleus, then we gotta do the dot for the nucleus, then we gotta do circles around it, equal to 2 because it's in the second period. If it was in the third period, we would draw 3 circles. If it was in the fifth period, we would draw 5 circles, but it's only in the second. Then we have to place our dots, we place 3 dots because of 3 valence electrons. 1, 2, 3. We stop there because that's how many there are. All right, helium. Helium is a little special. First off, what period is helium in? Helium is in the first period. Then we need to figure out its valence electrons. If you look at your label periodic table, you would say, oh, it has 8 valence electrons. It's over in that, it has 8 above it. But it only has 1 period, so the max number of valence electrons it can have is 2. So we do 1 dot for the nucleus. We do a circle around it for the 1 period. Then we have 2 valence electrons. This is where it can get a little tricky. It just depends on who you are. Some people like to place a dot at the top, dot at the bottom. I like to place both my dots right next to each other when I do helium. And this is helium's Bohr's model. All right. Now, reading a Bohr's model. You can also look at a Bohr's model and figure out what element is representing. All you have to do is identify the period and the valence electrons. So if we look at this model here, try and figure out what period it's in. How many circles does it have? Well, it has 2. All right. And then how many valence electrons does it have? Well, it has 2 valence electrons. All right. So what you do, you go on the second period with 2 valence electrons and see where they to cross. Where they cross would be their element, and this element is beryllium. All right. Now, something that goes along with Bohr's model is something called the electron dot diagrams. You can kind of see them in the picture over here. The electron dot diagram is a model of the atom which each dot represents the valence electrons. The difference here is we don't have to draw the circles. We just have to do the dots. Sometimes this is also called Lewis dot structures, based off the person who developed them. So the steps. First step, you're going to identify the valence electrons, the number of valence electrons. We have neon over here. So how many valence electrons does neon have? It has 8. Then we're going to write the symbol, the element symbol. Neon's symbol is Ne. Then we're going to place dots around the symbol in correct order equal to the number of valence electrons. In correct order is just like we do with Bohr's model, but we're doing the electron dot diagram. So 1, 2, 3, 4, 5, 6, 7, 8. Because of 8 valence electrons. And this is the dot diagram for neon. So let's do a couple more examples. We have fluorine here. First thing we need to figure out is how many valence electrons does fluorine have. We look on our periodic table and fluorine has 7. Then we write the symbol for fluorine. Fluorine's symbol is F. Then we're going to place 7 dots. 1, 2, 3, 4, 5, 6, 7. Stop real quick. Try sodium and try carbon on your own. I'll count to 5 and then I'll begin. 5, 4, 3, 2, 1. All right, sodium. Sodium's valence electrons is first identified as 1 because we get it from the periodic table we labeled. Then we write the symbol for sodium. Sodium symbol is Na. You should have got that off the periodic table. Then we're going to do our dots, and it's 1, so 1 dot right up here. And that's sodium. All right, carbon. How many valence electrons does carbon have? It has 4. Symbol for carbon is C. Then we do our 4 dots. 1, 2, 3, 4. And that is the dot diagram. Hope you learned something today. Practice these out. Come back for more videos. And I'm Mr. Norris. I'm signing out for this video.